Access control models explained through a mob analogy. Let's start with the big boss, called the MAC. And the MAC stands for Mandatory Access Control, and this means that all control is managed from a central authority. However, there is a plot twist to the MAC. So let's imagine that the MAC boss is sitting there talking to his mobster gangsters, because the topic of security labels and classification is being brought to the table. But here's the plot twist. You see, the Mac boss is not the human boss sitting in the chair, but it's actually the computer sitting on the boss's desk. Yes, you heard that right, because under the Mandatory Access Control model, the Mac, this is a system in which the system, being the computer, not the human user, decides who can access the data. The data in this analogy being all the weapons used by the mobster gangsters. Furthermore, every subject, aka the mobster, and every object, aka the weapons, is assigned a security level, such as confidential, secret, or top secret. However, important technical keynote, as a user you cannot change or override these access rules, even if you are the data owner, aka the weapon owner, because the MAC model is a very strict model that works off the labels and classifications, which means if your label and classification does not match, then you have no access, because the system checks these labels before allowing any access and uses strict rules like no read up, no write down, which means that all decisions are automatic and enforced consistently across the entire environment, aka the mobster organization, which means even the big boss himself cannot override the computer's strict rules. So knowing all this, let's look at the benefits and drawbacks of using mandatory access control, starting with the benefits. The obvious benefit being that the mandatory access control provides very strong protection for highly sensitive or regulated data because users have no control over the access permissions, only the system does. But this in turn is a drawback as well because security is more important than convenience, which means the mandatory access control model lacks flexibility because of these very strict labels and classifications. And in the mobster analogy, these labels and classifications and having to ask the computer for clearance is not good for business, especially mob business, because the mobsters need user discretion in order to do their hits when the time is needed, or even switch roles if the situation arises, and therefore the mandatory access control model is not useful for this particular purpose. However, for government agencies, the mandatory access control model is great for handling classified data, because the strict labeling and classification levels reduces the risks of any accidental data leaks or privilege misuse. So the human mob boss in this analogy agrees with his mobster gangsters and decides to ditch the mandatory access control model in favour for a better model that is a bit more suited to the organisation like the mob, where user discretion over data, aka weapons, is absolutely vital, and this leads us to our next access control model, known as the DAC, Discretionary Access Control Model, which is in stark contrast to the mandatory access control model, because in the DAC model, the owner of the resource, aka weapon, decides who can access that weapon or data. In other words, it's the user's discretion or the owner's discretion. So whilst the computer system enforces the DAC model, the user, the owner, decides on the permissions ultimately. And the permissions used in the discretionary access model are those similar to an operating system that we use today, that is using a read, write, execute, or a combination of all three, RWE. But ultimately the key takeaway is that the owner sets the permissions and the system enforces those permissions, whereas in mandatory access control the system is in full control. So to expand this analogy, let's imagine that the mob owner adds a new gun, weapon to the resource pool, aka weapons pool. And because the boss is the owner of the weapon, the boss ultimately sets the access control for the users. For example, if a user can read, write, or execute, or even all three, read, write, execute, RWE. Furthermore, even the individual mobster gangsters can add their own weapons to the weapons pool, and because they would be the owners, they can therefore assign the user access permissions assigned to that weapon. So that is a big benefit of the discretionary access control, and on that note, let's look at the benefits and drawbacks of the model as a whole. Well, DAC is easy to understand and simple to manage, especially in smaller fast-moving teams like in the mob, and this allows flexibility when sharing information and collaborating across teams, such as all the different mobsters and the territories. But the DAC model does create security risks, in that if the users, aka owners, accidentally assign the wrong access or overshare sensitive data, this could be very dangerous for the mob. especially if certain users, aka mobster members, get access to weapons that they weren't supposed to have, and they can execute these or even write these. These can cause some serious danger and misconfigurations across the organisation. After all, nobody wants their crazy uncle having access to all the weaponry in the arsenal. But an even bigger risk of the DAC model is if a rival gang or territory gets access to the weapons due to the misconfiguration of user permissions. And because of this user discretion risk, the mob boss decides to ditch the discretionary access control model, because you can't trust the users, aka mobsters, to assign the right permissions and keep track of these over time. But having already tried the mandatory access control model, which was all about the computer, and having tried the discretionary access control model, all about the user discretion, what other models are there? Well, there is RBAC, which stands for Role-Based Access Control, which is very easy to understand conceptually, but is still hard to implement correctly in organizations. To help explain this, let's imagine we have some roles within the mob, starting with the associates, the non-workers, then the soldiers, the workers, and of course the capitano, the captain. And in the role-based access control model, the first stage is to assign permissions to these roles, and then the users are assigned to those roles, and automatically inherit the associated access rights with those roles. Furthermore, if a user's role changes, their access updates automatically based on their role assignment. So with that said, let's look at the overall benefits and drawbacks of using role-based access control. So the biggest benefit is that RBAC compared to the MAC and the DAC access models simplifies access management and enforces least privilege, because users are only assigned access and permissions relative to their job role, which they inherit from that specific role. So instead of managing users at the individual user level, you just manage the users through the roles, and all the rest of the permissions are associated to that role. But what are the drawbacks to this? Well, RBAC can become inflexible if these roles are not carefully designed or kept up to date. And what usually happens is that too many roles get created and then job exceptions get created, which then causes more problems down the line. Because remember that people's job roles don't always define what they actually do, especially in fast-moving organisations like the mob. So maybe RBAC is also not good for the mob. Nor was the DAC or MAC access models explained earlier. So we are running out of access control models, but is there any others that might just fit the mob's needs? Of which there is one more access model known as ABAC, Attribute-Based Access Control. And ABAC evolved from the RBAC, Role-Based Access Control, in order to handle more complex context-aware security needs for the mob. And it does this by introducing attributes to handle dynamic factors, unlike RBAC, which uses predefined roles. So what exactly does this mean? Well, let's use the early example of RBAC and see how attributes through ABAC are applied. So RBAC would be the role, e.g. the captain, the captino, at the most general level. However, ABAC controls add attributes such as captains in a certain territory or street level racket, aka context aware. And this is one of the biggest benefits of using attribute-based access control. In fact, ABAC works well with modern environments such as the cloud, remote working, and even zero-trust architectures, because of its very fine-grained control over access decisions, and therefore better reflects real-world context rather than just static permissions and roles as discussed in the earlier access control models. But ABAC does have some downsides in that you need to have very careful planning, rules, and strong governance, because it's not just the roles that you are considering, but also the attributes, aka what those roles can do, and all the context-aware situations. So it may be that attribute-based access control is actually the right solution for the mob in this analogy. However, here's another plot twist. There is no right answer, because the needs of your organisation are what decides what access control model you decide to go with. If you found this video informative and enjoyable, it would be awesome if you could like and subscribe if not already to help support this new channel's growth. As without any likes and subscribes, ladies and gents, it's very hard for me and YouTube to figure out if you are enjoying these videos, and I would love to keep making more if you are.